Don't waste time in starting this behavior-driven Python testing. We have seen augmenting behavior, human behavior in making a stylish clothing, but how do we test that? We have driven Python testing. We have coded a right Python using the behavior-driven testing. So I would like to introduce Mr. Andrew Knight, who is calls himself as Automation Panda. Let him. I'm introducing him to you. So let's start the session quickly. Yeah. You have you have a questionnaire 5 minutes after the session ends, maybe about 12:20. So please don't raise your questions till that moment. Hold your questions till the end. Thank you. Please go ahead.
Thank you. Cool. Thank you. It's good to be here. My name is Andy Knight, as was said, and I'm going to talk with everybody today about behavior-driven Python. Just a little bit of background about myself. I'm a software engineer. I'm very much a developer at heart, but in my day job, I focus on testing and automation. I've got my Twitter handle, Automation Panda. Feel free to hit me up after this talk. I also have a blog, automationpanda.com, that will have a bunch of resources to support my talk here today. So what we're going to talk about is behavior-driven development, or BDD. Has anybody heard of this before? Probably Gherkin. Yeah, woo, go BDD. And I'm going to focus specifically on Python's behave framework for test case automation. Let's give an introduction to what behavior-driven development is. And by starting with that, we need to look at what a behavior is. The dictionary defines a behavior as the way in which one acts or conducts oneself. In software, a behavior is how a feature operates. A good way to think about it is like a feature function. Behavior has three parts. Has a defined set of inputs, it has a defined set of actions, and then it has a defined set of outcomes, the holy trifecta. And when we think about software and the products that we make, a product or feature can exhibit countless behaviors. Things such as submitting forms on a website, or searching for desired results, saving a document, making REST API calls, even running CLI commands. They're all things, facets of a product that has a starting state, we do something, and we expect to get something back. And behavior-driven development is a software development process that puts main emphasis in the development process on these behaviors. How do we define them? How do we develop them? And how do we test them? It complements Agile. It's not like a overhaul or anything. But the key thing is focusing on behaviors using what we call specification by example. In specification by example, what we do is we write what our expected behaviors are using some sort of formalized plain language. If anybody's heard of Gherkin or the Cucumber project, those given when then scenarios, that's one of the most common specification languages in behavior-driven development. And they're not meant to be programming languages. They're very much specification languages. They're supposed to indicate what happens, not necessarily how it's implemented underneath. Keeps it very high level. And as part of our development, from the very beginning, we should be writing these behavior scenarios so that we know exactly what's going to be developed, and that carries through the process. So we avoid this nasty game of telephone. If he said, she said, this is what I thought I was going to get, but it's not. Also, when you have something formalized like that, you can easily turn those scenarios into automated tests, and that's where you get a lot of bang for your buck. Every step in your behavior scenario can be glued to some sort of implementation code to say how that step runs. And when we think of behavior specs, then they really become the units of coverage for feature testing. Python has a bunch of really cool BDD frameworks. Today I'm going to focus on the behave framework. If you haven't seen Gherkin before, here's a quick example scenario. 3 basic lines, basic DuckDuckGo search. Given initial state, the DuckDuckGo homepage is displayed. When you take an action, the user searches for some phrase, panda. Then, what do you expect as an outcome? Results are shown for panda, that search phrase. Without knowing anything about how the DuckDuckGo page is implemented or anything like that, it's fairly safe to say everybody in this room can understand what the expected behavior is. Am I right? Yeah, cool. These behavior scenarios are meant to be concise, they're meant to be focused, they're meant to be meaningful, and they're meant to be declarative. They focus very much on what? It's meant to be high-level specification so that we're all on the same page. So why would we do this? What benefits do we get from doing BDD? The two major benefits are collaboration and automation, right? BDD helps us do these things better. What's really nice is that everybody can contribute to development, not just programmers. It helps your product owners and product managers get involved in the process from the start, who may not have as much of the technical background as, say, an engineer. You also have those expected behaviors defined at the beginning. You'll hopefully, with that, sort of eliminate miscommunications as you develop. Another nice thing is that tests can be automated together with the features they cover, because you know exactly what the steps are that will be part of your test scenarios. Each test covers a single unique behavior, so you avoid duplicate test coverage. And when you run, you know what your failure is precisely. And finally, the big one is the snowball effect. Those steps that you saw can be reused by different scenarios. I hit a point in a recent project I was working on where whenever we would automate new tests, we didn't even need to write new code because we already had the Gherkin steps that we could reuse. It was awesome. And so BDD can really help to expedite your test automation, which we know is a persistent challenge with short deadlines. Now that we know a little bit about BDD, let's dig into the Behave framework. Behave is a Python test framework. It's very, very similar to Cucumber or Spec if you've heard of those. There are two main layers to the Behave framework. Your top layer is where you write your behavior specs, and you write them in this language I mentioned called Gherkin, and we'll see more examples of Gherkin in the future. You will save your Gherkin in .feature files, and they will very much have test focus, right? What is the thing? The lower layer in Behave is what you call your step definitions and your hooks. This is where the Python comes into play. You're going to implement every single one of those steps, and your Python code is going to have automation focus. That's where you put in the details of the how. So, layered approach. As we saw before, Gherkin scenarios use plain language. Given some initial state, when an action is taken, then verify some outcome. Given, when, then. Each of those steps will be glued to a Python function when the Behave test runs. To install Behave is pretty easy. Just grab it from from pip. Pip install Behave. You may want to have some other packages for testing, things like requests or Selenium, depending on the type of test you're doing. But just the raw framework itself only needs the Behave package. Shout out, I also recommend looking into pip and V. Pretty cool stuff. So with the two layers of our Behave framework, let's look at the top layer, Gherkin features. Here's a more comprehensive example of what a feature file could look like. Now I've made a fake feature, just for example, called a cucumber basket. At the very top, you see the feature title. That's a keyword in Gherkin, and you give it the actual title of the text. Underneath of that are free-form comment lines. These are not executed in any way. They're just there to help give context. As a best practice, especially if you're doing Agile, I recommend putting the user story in there to help understand what the feature is. So, as a gardener, I want to carry many cucumbers in my basket so I don't drop them all. That's why I want a cucumber basket feature. Now, a single feature section can have multiple scenario sections. This one has only one just because my slide is only so tall. The scenario, again, scenario is a keyword. Add and remove cucumbers is the descriptive title that will appear in the logs for this test. And then under there, I can have any number of steps. Given the basket is empty, that's an initial state, when 4 cucumbers are added to the basket. Now notice how that is in double quotes, and I've highlighted it in orange. Your steps can be parameterized. This helps with that reusability of your steps, because I can use very similar steps like the next one, and 6 more cucumbers are added to the basket. Underneath, you could probably have the same Python function implementation for both of those. but 3 cucumbers are removed from the basket. Now we've seen how we can add steps and but to any step type. It's just like having 3 whens instead of having 1. There's no semantic meaning to and or but. It's just associated with the previous type. So 4 cucumbers are added, 6 more are added, 3 are removed. Then what do I expect? How many cucumbers left? 7, right? And that's my final step there. I recommend a strict given when then ordering because that helps to frame individual behaviors per scenario. I also recommend adding these tags, this @cucumber_basket. Those are simply identifiers that we can use for test filtering and hooks, which we'll see a little bit later. Think about it as test categorization. Gherkin also has some more advanced language features to it. I showed previously a scenario where I add and remove, but what happens if I have a feature file with multiple scenarios and they all have the same setup? This is very, very common in test automation. Well, what I can do is I can put any common steps that need to be run before other scenarios in what I call a background section. Notice it doesn't have a title and it just has regular givens, whens, and thens. Best practice, you probably only want to put givens in a background because they're focused on setup. But here in this feature, I could write it like this. As a starting point, given the basket contains 5 cucumbers. Now, for the other 2 scenarios, that's the starting point, 5 cucumbers. So I can remove some code duplication by saying, in my add cucumbers, I can go directly to the when some cucumbers are added. Likewise for remove, when I remove cucumbers. The background section will be executed once per scenario by the automation. It's not once for all, it's once for each. And you can also have scenario templates or scenario outlines to maximize the reuse within your Gherkin. There may be times where your scenarios you need to run for multiple input combinations. Rather than copy-pasting the same scenario and twiddling the inputs, you can use a scenario outline like this. Instead of being called scenario, the keyword is scenario outline. And anytime you want to do a value substitution, you put it in these angle brackets. Then down below the scenario outline, you have what you call your examples table. Here I've titled it cucumber counts. Each column in the table represents values to be substituted. So notice how the names match up: initial, more, and total. Each row represents a unique combination of inputs to run for a scenario. So in this case, since I have 3 rows, ultimately at runtime, this scenario outline will be run 3 times total, once for each of these input combinations. And when it runs, they substitute. It's as simple as that. There's more to the Gherkin language. It's not that much more, but there are some additional things like comments and step tables and lengthy strings you can add. I recommend going to look up all that stuff online after the talk, but what we've learned so far is good enough to keep going. So now that we know how the Gherkin layer works with our given when then scenarios, let's take a step down to the lower level and look how the Python mechanics work. Step definitions, quote unquote, are the names of those Python functions that will provide the implementations to each one of those Gherkin Englishy steps. How it works is that in your Python module, you'll import the behave module, and you'll start adding given, when, and then decorators to functions that you want to glue to those Englishy steps. Notice here, I have 3 example functions. Given the basket has some initial parameterized number of cucumbers, when cucumbers are added, and then the basket contains total cucumbers. There are a couple ways you can do step matching. The default is using the parse library. It's fairly standard, and that's what's shown here. It's typically the easiest for most purposes. You can also use CF parse and full-on regular expressions. There's some nifty things you can do to match. The key thing is you're matching text to code. And this is what it looks like when you glue them. So on the left, I've got my feature file. Given the basket has 4 cucumbers and 3 are added, then the basket contains 7. Each one of these steps will go to one of those Python functions at runtime. Now, one challenge with this is making sure that your data is safe when you run a test. You can have all sorts of functions out there by themselves, but how do they know how to interact? Because a test is very much like a builder. You do one step, then the other, then the other, then the other. That's where scenario context comes into play. Notice in my step definition functions, every single one of them has this context variable that's passed in. Behave will inject that for you automatically. That context variable will hold data specific to that scenario. You can access things like the title, the tags, the feature it's in, and furthermore, you can also add arbitrary values to it. This is the best way to pass data from one step to another. So notice how for my cucumber basket, I'm saying context.basket gets some new cucumber basket instance. And then later, my when step is presuming that basket's there because it's preceded by the given, and I'm taking action on it. Same thing here, I'm accessing the count of the basket. This is the proper way to share context between steps. As a warning, do not use globals to share data in test automation. It's bad design, and it can also break parallel execution. Now there's also this thing called hooks. When we write our given, when, then scenarios, they're very much a test focus. They don't specify nitty-gritty details of how the automation is supposed to run. But we all know there are certain things at the automation level, before and after features or tests or even steps, that we need to handle. A perfect example of this would be WebDriver setup and cleanup. If you've done any sort of web testing, you've probably used something like Selenium WebDriver or Waiter or Splinter. It's typically a good practice that before the scenario begins, I want to create my WebDriver and then inject that reference into my test. And then at the very end of the test, no matter what happens, I want to make sure that I quit that browser instance, or else I've got processes going rogue on my machine. So hooks are the way to do that. We can add them to an environment.py file in our project, and we can specify before and after all those different point cuts in our execution time. This is very similar to aspect-oriented programming, if anybody's familiar with that. And so the example I have here is that WebDriver. I can also selectively apply hooks to different tags. So here, my before scenario, if web is in my tag, in my context of tags, meaning my scenario is tagged with web, then set up Firefox driver. And at the end, no matter what, make sure I quit. Some people will try to put this type of cleanup in a then step. Problem is, if it blows up on a when due to a bad assertion or something, you never get to the then, it doesn't execute, and therefore you don't clean up. So just pro tip on that one. You can also use fixtures to do setup and cleanup. It's very similar to hooks. It's just another mechanism specific for that purpose. Here I've got an example of doing a Firefox browser where it's the same logic, just in a different format is all. Now, let's talk about directory layout. We know we have all these cool pieces we got to fit together. Where do they go? Behave is picky about your directory layout. It expects everything to be under a features directory. All your feature files and your environments go directly under there. And then under features, you need to have a steps directory where you have all of your Python modules that provide the step definitions. You can customize this with the behave config options. I know it's very popular to put tests under a tests directory. But I also want to shout out, your feature file names do not necessarily need to align equally to step definition names. They can be different. Any steps can be used by any feature file. That's the snowball effect. Behave by itself is great, but I strongly recommend that you use other packages as well. Modern test automation development is not about building things from the ground up. It's about picking the ingredients off the shelf and making a nice recipe. So you may want to include things like logging or requests or Selenium when you start doing using behave. And always make sure you use good design patterns. For example, if you're doing web testing, you probably want to look at screenplay pattern or maybe page object model, something like that. You want your step definition code to be concise. So running tests, very simple, just use the behave command. If you just use behave, it'll discover all tests in your project and run them. You can also run them specifically by feature file, and you can also filter by tagging. Here are some different options. Full Boolean logic is supported. If you need help, tags help. You can also put some execution options in config files, like behave ini or setup config. They all follow Windows ini format. And you put them in your project root directory or in your home directory. Some other options, that could be helpful that I haven't shown. Things like different logging level options and filtering, or maybe you want to generate a JUnit report, stuff like that, all can be configured there. Command line options always override config file options, FYI. Some other final testing considerations: use virtual environments. That's just good practice. Things like virtual env or pipenv are great tools. Make sure you put your test dependencies like behave and as development only dependencies so they don't go to production. Word to the wise, behave, the framework itself does not support parallel execution out of the box. There are some offshoot projects. You can also make your own kinds of schedulers. Just know that that's something not in the framework. And build server integration is easy, especially if you use virtual environments. You can just pop it in and go. If you do something like Jenkins, you can use JUnit reporting to integrate into that. So final remarks real quick. Behave is not the only BDD framework in Python. There are a number of others. Behave is one of the more popular ones, that's why I chose to talk about it today. But it warrants to see a comparison to some others. PyTest BDD is out there as well. I really like PyTest BDD because you get all the goodness of PyTest, which is, in my opinion, one of the best Python frameworks out there. What's also nice about PyTest is that if you have traditional PyTest functions, they'll integrate very nicely at runtime with your BDD Gherkin scenarios. The filters will all work the same. And also PyTest is a little more forgiving in its directory layout. Some others to mention, there's a project called Radish out there. It's very, very similar to Cool, somebody shouting out in the crowd. Yeah, Radish is really cool. It's compatible with Cucumber Gherkin, but it's like Gherkin Plus. You get things like scenario loops and preconditions added to Gherkin. So it's more programmer friendly. And Radish also has very comprehensive command line options, which makes it great to use. Finally, there's a project out there called Lettuce. It's very, very similar to Behave. There's just some small framework mechanics that are different. I know some people like to use it. Though I will caution, I haven't seen very much GitHub activity on the Lettuce project recently. Beyond Python, keep in mind that frameworks like this don't necessarily need to test Python code, right? If you're testing REST APIs or a website or something, Python test frameworks can be used for any type of black box testing, even for non-Python products. And I'll conclude by saying I have a bunch more resources for behavior-driven development and Behave Online on GitHub. If you look for behavior-driven Python, that's an example project that will show how to do the tests that I've shown here in this talk. You can also go to my blog or hit me up on Twitter if you have questions or anything. Great, thank you. Oh, sure, yes, absolutely. Everybody's hungry for lunch, I suppose.
Yeah. So for each of those what do you call them, tags? Like for the like when and like a step implementation, for each of those steps, can you specify like assertions to be run at the end?
Yes, absolutely. Okay. And in fact, you would want to put assertions into your then steps because that's what they're meant for.
Okay, right. And so and it can be like asynchronous.
I've never tried asynchronous BDD.
So like for like Selenium testing, like would you be able to have your step wait for a particular change to happen?
Yes. Typically when you do web testing, that's what you do. Because it's I mean, one of the problems is always race conditions, right? You send something out and you just kind of wait for something to be ready on the page, and then you proceed.
Okay.
Things like, I click a button, I wait for the page to load, I wait for the title to come. Okay, now I know I'm good to start clicking new buttons on the page.
Right. Okay.
Yep,
Cool.
no problem.
Hey, Andy. Is this on?
Oh. Go ahead. I'll ping pong between these.
Okay, sounds good. Hey, when I've started getting into Gherkin more and more, I've heard a lot about acceptance test-driven development being what I should do there, and that it should only be testing input and output. When I'm doing behave and I'm talking about like an API, it seems really strange that I don't have assertions like log was written correctly, database received data correctly. How do you recommend actually testing those internal side effects as part of an API?
I recommend taking an automation pyramid approach. Behave is a very flexible framework. It can be used for multiple things. I could use Behave for unit tests. Now, I don't recommend that, but you could. It sounds like you're talking about two different test layers. You're talking about if you have unit tests, which is way below. You then have integration tests, which are the points where systems come together. You make sure database is in there. And then you have end-to-end tests, which are meant to be more of testing like a user would test. So I would say it's not so much about a framework or about a good Gherkin thing. It's more about the intention of what you want to test, right? So if you're going to be writing end-to-end level tests as a user would, then no, you're not going to want to be writing steps that are very nitty-gritty, like make sure the database has this and make sure it times out after however many seconds, right? If you are writing integration level tests, you would want to specify those behaviors at that level then. Does that make sense?
Yeah, so mechanically, would that be a tag that I would say run my integration tests? Because it seems very natural to write that in Gherkin.
You could have feature files that are entirely integration tests and tag them as at integration. And then in the same project, you have web tests that you tag at web. And so then let's say in a build pipeline, okay, you made your build, you've deployed it to a test environment. Okay, first phase, run all the at integration tests. And then second phase, run all the at web tests. And then boom, boom.
Awesome.
Cool.
Thank you.
Thank you. So I'll ping back over here.
So is there tools out there that do the parallel testing or concurrent testing, for example, executing the scenarios simultaneously? The motivation is if I have thousands of tests, I want to reduce the testing time.
Yeah, so you're asking for parallel test execution? Yes, there are things out there. Like I mentioned, it's in the Behave framework, they don't have that implementation. In fact, there's open tickets to try to get it in, and it looks like there's a little bit of religious warfare going on. I'm staying out of that. But there are offshoot projects that do parallel execution with Behave. And you can also make your own sort of manager, right? It's just processes, right? So you could make a script that says, okay, run 5 processes. First one runs this tag, second one runs this tag, and then you can kind of manage it yourself. Cool. Thank you. Yeah. Time is up.
I'm sorry
Okay.
to interrupt, but you may catch up the presenter later with the session.
Come get lunch
Thanks,
with me.
Andy, for giving a nice session.
Oh, thank you.
Whomever, you can give the best, please. Yeah, thank you.